Hello, algebra students. We're going to review for the Indicator 12 quiz. This is similar to the review that we did, that we handed out to you guys to work on. It's not exactly the same, but similar type problems. So let's get started. So this first one says find the range of y equals 2x plus 1 if the domain is, and it gives the domain 4 different values for x, and it says express your answers as ordered pairs. So we want the range, it gives us the domain, and the domain is just those 4 values. Domain, remember, means all the possible x values. So that is all of them. And so if we put those in, we will get all the possible y values, right? There's no way to get any other y values because we will have done all the possible x's. So we make a column for x and we put them all there. And then we'll have a column to calculate our y value for each of those. So we can put that as the heading of that column. Another column to write the result for each, and then a column for the ordered pair, because this question says express your answers as ordered pairs. So here's where we do the calculation, and it's going to be 2x plus 1 each time. So we can write that as writing parentheses in as a place to plug in for x, and so that means 2x plus 1, right? We just plug in for the x. So you can write those all down pretty quickly. So this is not a problem that has to take a lot of time. Sometimes it looks real daunting to think, oh, I have to calculate all those. Well, write this down, and then you plug in the numbers, and then you're ready to calculate. So the first one, 2 times negative 3 is negative 6, plus 1 is negative 5. Then the next one, that multiplies to negative 2, right? Then plus 1 is negative 1. The next one multiplies to 0, plus 1 is 1, and the last one is 10 plus 1, which is 11. That gives us all the y's, but this says express your answers as ordered pairs, so we write the ordered pair for each of those. Okay, that is the x and the y. We're going to write the number from this column here, that's our x, and the number from that column, that's our y. Okay. So for the next one, negative 1 comma negative 1, then it's 0 comma 1, and then it's 5 comma 11. And that's it. You can circle those ordered pairs if you want to. You don't really need to, though. I can find them when I'm grading. Okay, so the next one is this the kind of problem that we like. State the domain and range of the following relation. So we can just write something like domain, colon, and then put brackets around it. I'm not going to be a real stickler on that. I like to use the curly brackets or braces, depending on what you want to call them. So all the x values, that's just the first number in each ordered pair. I'm going to write these down in the order that they appear, and that's okay with me. You don't have to necessarily write them in order from smallest to largest or least to greatest, but you can if you want to. But it's not a big deal to me. You have to check with your teacher in a later class and see how they want you to do it. So we have 6.25, then negative 6.25 is the next x that appears, and then the next one is the 5, And then the last one, we've got another 5, but we don't have to write down 5 twice, and we shouldn't. We should only write it once. Yeah, I inadvertently erased it. So we've got all 3 of them. There's only 3 different values, the 6.25, negative 6.25, and 5. Okay. So now the range. It's just the second number in each ordered pair. So that's negative 6.25, then negative 0.5, and it says negative 0, and that you can write it as negative 0 or just 0. Okay. Next one is one of those with the graph. Some people find these pretty easy. Sometimes they just seem a little harder for some, and you just have to keep working with them if you have trouble. State the domain and range for the graph. Write your answers as compound inequalities. So they're helping us out here a little bit. Write it as a compound inequality. So we want to show what is the smallest number that x can be and what's the largest. And we see this graph is continuous. So there is an ordered pair that has any x value anywhere in there. So that's why we can't just list, for example, this would be wrong. We can't just say negative 2, negative 1, 0, 1, 2, 3, 4. That would capture all of the whole number points, but what about 2.5? X could be that, right? X could be 2.6, 2.7. X could be 3.1, 3.11, 3.2. X could be a lot of things. So it doesn't work to just list the whole numbers. We have to show a compound inequality that specifies all the numbers that all the possible x values for this relation. So we see, well, the farthest one to the left we can tell, and that's negative 2. So that's what you're looking for. What's the farthest one to the left? And then we just know x has to be bigger than that. X has to be to the right of that. So we say negative 2 is less than or equal to x. That can also be read x is greater than or equal to negative 2. Okay, x is on this side of negative 2. So we then have a limit on the other side, though. X has to be less than something. I need to erase. Here we go. Sorry. Erase that. I don't want that up there anymore. Whoops. Erase too much. Okay, so how far to the right can x go? It has to be less than or equal to the rightmost point of the graph. And that's right there. That's as far right as the graph goes, correct? So that's 4. So that is the limits that are put on x. X can be anything between negative 2 and 4. Okay? So now we'll look at the range. So we have the same type of thing for y. We now look at how far up does this graph go? What's the topmost point in the graph? And it's right here, right? So we can draw the line over to the y-axis and say, aha, 3. That's as far up as it goes. That number goes over here, right? We say y is less than or equal to 3. But then how far down can y go? Well, let's see. The farthest down point of the graph is this right here. Okay, and what is that? We make a line there. the very bottom of that graph. And we see that's -1. So one approach to this is to just make a box that encloses the entire relation, the entire graph. And when you make that box, then the bottom of the box and the top of the box give you the limits on y. How far down can you go and still have possible y's, and how far up can you go? So you go down to -1, and that's that. You could go up to 3, and that's that. And for that same box, we'll show you how far to the left you can go for x, back to -2, and how far to the right, and that's 4. Okay. So let's see what else we got. Which ordered pairs are solutions of the equation? Make sure we get it all on there. 5x equals 2 minus y. So it gives us 4 ordered pairs, A, B, C, and D. And it just asks which one are solutions. So we've got to try them one at a time and see which ones are solutions of that equation. So we can write this 5, and then we plug in x. So I'm going to write parentheses and equals 2 minus y, and we plug in y. So let's write parentheses there. And then we can label these to make sure we don't mix them up and put the wrong one in the wrong place. And I'll tell you guys, at my advanced age, I need to do things like this, try to cut down on errors. So bear with me. You may think you don't need to do that, and you may not need to, but I'm going to do it like this. So I plug my x in here. So 3, the first number in the ordered pair, and my value for y I plug in here, and let's just see if that ordered pair works, if that value of x and y works. So we do the calculation. That's on the left, it's 15 equals 2 minus 12. Okay, and that is not true. Okay, that's false. So that one doesn't work. We try them all. Just like that, we have 5x, and then equals 2 minus y. Plug in our numbers. For x, it's the first number, it's 2. For y, it is -8. So 5 times 2 is 10. 2 minus a -8, that's 2 plus 8, that's 10. Yeah, that is true. So that one is a solution. Okay, let's look at the next one. 5 times x, that's 5 times -3, right? Equals 2 minus y. That is, this time, -17. Okay, so 5 times x equals 2 minus y. And so that's -15 equals 2 minus -17. That's 2 plus 17. That's 19. So don't, be careful. If you see the 2 and the 17, you may think, oh, let's see, I think that's going to work. 2 minus 17 is 15. Yes, 2 minus 17 is 15, but that's not the calculation this time, right? This says 2 minus y, and y is -17. So we're taking 2 minus -17, that's 2 plus 17, that's 19, and that one is false. Okay, so let's look at the next one. We have 5 times x equals 2 minus y. We plug in for x, we plug in for y. And that gives us -5 equals 2 minus 7. So I believe this one does work. I put in y exactly. I put in 7. I think it's right. Negative 5 equals negative 5. That is true. So unless I made a calculation mistake, that one is a solution. Okay? So there's one more on this page, and we've got another page. Yay, more problems. So it says, find the range for x plus y equals 5. If the domain is, and there's the domain, 5 values, express your answers as ordered pairs. So we'll do like we did the last one. We have x, a column for x. We have a column to do our calculation, and I'm going to wait and fill that. We can't fill that in exactly, can we? Because we're not told what y equals. We do not have it in that form. We have this equation right here, and we're told find the range for that. But that doesn't say y equals, does it? So we have to think about that a second. So we'll come back to that. We'll make the column for y once we calculate it, and we'll make the column for the ordered pair. So how do we calculate these? What do we do here? Well, we have to recognize that we are not given that, but the function is given to us in another form, and this is actually a somewhat advanced topic in mathematics. This is called an implicit function. So normally a function says y equals something and gives us a rule to calculate it, and it might be written as f of x or g of x equals something. It's the same thing though, whether it says f of x or g of x or if it just says y. The idea is the same. The rule lets us calculate what y is for that x, like this first one did. We had it right there. Okay? So that's the typical way, but the one we're doing is called an implicit function. It's also a function because for every x we plug in, we can calculate a y. But we don't have it, the rule explicitly, so we would have to do something like this. Look at that equation, x plus y equals 5. Plug in for x, like our first number, negative 2. Okay, put that in for x and write the equation down exactly. X plus y equals 5, well, negative 2 plus y equals 5, plugging in the negative 2 for x. And then we can solve for y. Add 2 to both sides, and we get y equals 7. And we could do that for each of these values. And let's do one more. X plus y equals 5. We're going to put in this time negative 1 for the x. Negative 1 plus y equals 5. Solve for y now, because for any x we put in, we can solve for y, and that gives us the y that corresponds to that x. We add 1 to both sides. We get y equals 6. So we could do this for all 5 of them and get all 5 of our y's. And that would work, and we could write those in this column over here, and we'd have it. But the easier way is to go ahead and solve that equation for y, and do that first, and then we will be able to write down the rule. Then we will have an explicit function. It won't be just implicit, but we will have the normal one that gives us the rule and lets us calculate y directly. So let's do that instead. We have x plus y equals 5. We just solve that for y. Put it in slope-intercept form. So subtract x from both sides. And that gives us y equals negative x plus 5. And that's pretty cool. We can put that here. And this really wouldn't take very long to do, right? It took a long time because I was explaining it. I went ahead and calculated a couple of these, which we really didn't have to do. If we're going to use the rule, if we're going to change it to this form, we don't need to do the calculation the first way that I did. So we have our rule. We put our x's down. We write what our calculation is going to be, which is negative x plus 5. We can go ahead and put that for all of them. Okay, and now we plug in the number. And now we calculate each negative of negative 2. That's positive 2, right? Plus 5 is 7. This one, negative of negative 1, is positive 1. Plus 5 is 6. And then the next one is just 5. And then negative 2 plus 5, that's 3. Negative 5 plus 5 is 0. So we have our y's. So, that wasn't so bad. We can make a column of our ordered pairs. Okay, and that's just the x value and the y value, right? Negative 2, 7, negative 1, 6, 0, 5, 2, 3, 5, 0. And we've got the ordered pairs. So we might notice the way we calculated them the first time, that's kind of the long way. The first one we got y equals 7. That's good because that agrees here, okay, with what we got doing it the quicker way. And the second we got y equals 6, and that agrees with that. So if those should agree, right? Either way should get us the same answer. Okay, so I'm going to take a quick look at this and hope I didn't do the whole thing wrong. Y equals negative x plus 5. Yep, looks like it's right. And I wrote it down in this column, negative of each number plus 5. So if they want them as ordered pairs, of course, you make that column as well. So there was one that like this on the review as well that I gave to you guys, and I'm pretty sure there was one on the homework also. Not exactly the same problem, but by one like this, I mean one where the rule for calculating y was not given explicitly, but instead you have an equation and have to solve it for y, or do it the long way and calculate each one individually. So wouldn't be too surprised if you have something like that on the quiz. It'll be a different equation, but the steps to solve it for y will be different, but you may have one you have to solve for y. Okay, so I've got another page of examples to look at, which is page 2. We'll go ahead and save this in case I want to go back to it. Oh, maybe I'd already saved it. Okay, good enough. So let's look at this. Okay, says state the domain and range for the relation. This is another one like we like. You just list all those x values, which is 2, negative 3, 2, 7, 4. And I don't care if, I wrote 2 down twice, didn't I? So let's go back. 2, negative 3, and then we don't need to put 2 again, and then 7 and 4. Okay, 2, negative 3, 7, 4. And that shows one advantage to putting them in order. You would be less likely to miss the repeat. If you wrote them in order, you would be saying, okay, 2, and then what's the next one? Okay, oh, there's another 2. We won't write it. You might be less likely to miss the repeat. But it's okay to put them in an order other than least to greatest. It's fine with me. So for the y's, the range is just 3, 4, 7, all different so far, right? Oh, another 3, so we don't put the 3 twice. -2. I think that's it. Okay. Let's look at the next one. Which ordered pairs are solutions of the equation? They give us the equation. We just have to check each of these, right? So y equals -4x plus 2. Y, and I'm going to label that. I'm going to put my y in there, but I'm labeling that set of parentheses y so I don't make a mistake. -4 times x plus 2. Okay, so we put in 0 for, let's see, no. We put in 2 for y, okay, and 0 for x. Okay, so that is 2 equals 0 plus 2. So that is true. Okay, -4x plus 2. Yep, equals 2. So it looks like that one works. The next one, again, we have y goes to the first parentheses equals -4 times x plus 2. And you don't have to do it exactly like this. I'm just doing it to try to cut down on errors. So our y is 0, our x is 2. And so we get 0 equals -4 times 2 is -8 plus 2. And that one's false. Okay, the next one, y equals -4x plus 2. The y this time is 10. X is -2, so you have 10 equals -4 times -2. That's +8. 8 plus 2. So 10 equals 10, and that is true. So that's another one. That's true. Then the last one, y equals -4 times x plus 2. So for y we put in 10. For x we put in 3. We get 10 equals -12 plus 2. Don't let that fool you. It looks kind of 10-ish. It's -10 though, right? So I'll double check that, but we put in 10 for y, -4 times 3 for x, that is -12. Okay, so that is false. Okay, so unless I made calculation errors, I believe it's A and C are the ones that are true. Okay, well, let's look at this one. State the domain and range for the graph. Express, let's see, I think, do we need to, yes, scan out a little bit here. Let's see. Get rid of that. Okay, this is another one of those domain and range with a graph. Express your answer as compound inequality. Okay, so for the domain, we're going to have a compound inequality. that will show how far to the left x can be and how far to the right. This time I'm just going to draw that box first thing. Again, you don't have to draw it, but the box completely holds the graph, but just barely holds it. Make the box as small as possible to contain the entire graph. What's going on here? Won't erase. There we go. So you do have to be a little careful with the box. For example, we don't try to write it down here because that would chop off this one over here, right? It has to contain the whole thing. So now we can look at x. Well, the farthest to the left we go here is right here, which is -2. So -2 is less than or equal to x, which is less than or equal to. Then how far to the right can it go? And that's right here. So that's 1, 2, 3, 4. Okay, and for the range, how far to the left can we, or how far to the bottom, sorry. And that's -3, less than or equal to y. It's less than or equal to, how far up? Up to 1, 2, 3. I believe that's 3. Okay. The domain -2 to 4, range -3 to +3. Okay. Let's see what else we got. State domain and range for the relation, another easy one. Domain, and just list the possible x's. 5, 2, -1, 0. And the range, list all the y's. 1, comma, -1, comma, -3, and then we have a 1 that's in there again, which we don't have to write it twice. We should not write it twice. Okay. So 1, -1, -1, -3. So now we have another one. It says find the range for x equals -2, y equals 6 if the domain is. So this one is another one of those with the implicit function. So we can make a table where we will put all of our x's in that column. We'll have another column to do our calculation, but we don't have that rule yet. We will get it. Another column for the y that we calculate, and another column for the ordered pairs. So this time, without a lot of explanation, I'll show you this problem doesn't have to take a lot of time. Here we go. We have x minus 2y equals 6. That does allow us to calculate the y for each x we plug in. We could put in an x and solve this for y, and then start all over, put in a different number in for x and solve it for y. But let's just solve it for y right now and put it in slope-intercept form, and then we can write that rule over here. Okay, here we go. So we're going to subtract x from both sides, and we get -2y equals -6 plus x. And now we divide both sides by -2, which means dividing each term here by -2. So that gives us y equals -6 over -2, that's 3. And then we could write this as -1/2 x. Okay, so a little bit more involved this time. Don't think I made any mistakes. Oh, wait a second. I did make a mistake. Start all over. Glad I checked that. I wrote this down as negative 6 plus x. Should have been the other way around. Okay, so scratch that. Sorry, guys. So, on the left we have negative 2y. On the right we have negative x plus 6. Okay? Okay, I think that's better. Now we divide both sides by negative 2. Let's see what we get. Okay, so we have y equals, and this is negative divided by negative, so that's half x. And here we have 6 divided by negative 2. That's negative 3. So we have our rule, 1/2 x minus 3. And we have ordered pair over here. So now we got it. Negative 6, negative 2, 0, 4, and 12 are the values of x. The rule is going to look like 1/2 times x minus 3, and we'll plug in each time. Okay. So I think I wrote it down correctly each time. So we put in the numbers. They were very nice to give us all even numbers, okay, because we have to multiply by 1/2. So it's great that they were so compassionate to us. So now we can calculate this. 1/2 times negative 6, that's negative 3. Negative 3 minus 3, that's negative 6. Okay, be careful with that. I like to say you can always write it over here on the margin anywhere you want. We took positive 1/2 times negative 6. That's negative 3. And then that's minus 3. And I'm not sure what that is, but I can write it as negative 3 plus negative 3. Okay, so yeah, that's negative 6. So you can take your time on those. Try to get them right. Okay, so the others will go quicker. 1/2 times negative 2, that's negative 1. Minus 3 is negative 4. The next one is negative 3. The next one is 1/2 times 4. That's positive 2. 2 minus 3 is negative 1. And the next one is 1/2 times 12. That's 6. Minus 3 is 3. So we've got our numbers. Our ordered pair, negative 6 comma negative 6 is the first one, right? Because you have the x and the y. Okay, so we'll put the rest of them. Negative 2, negative 4, 0, negative 3, 4, negative 1, and 12, 3. That should be it. Okay, so that's several more problems. I hope that helps, and I will see you later.